So what we have discussed is, let us recall back the characteristics of the wave. So what we understood from our concept is that the particles of the medium only vibrate at their respective positions, mean positions. Okay, the particles of the medium vibrate only at their mean positions. Okay, only the energy is being transferred from one place to another place, but the matter itself is not transferred from one place to another place. Okay, the particles of the medium do not move from one place to another. What you observe is only the energy is transferred from one place to another place. So during the wave motion, energy is transferred from one point to another point of the medium. Okay, but the whole medium will not move. What do we observe is only the disturbance is traveling through the medium. Only disturbance is traveling through the medium. And one more thing you need to remember, the children. So whenever wave is propagated along the medium, whenever a wave is propagated along the medium, that means energy is transferred along the medium, or the disturbance is transferred along the medium, everywhere the medium or the wave motion, the disturbance, the movement of the disturbance have the same speed at every point. Okay, that means in all direction the wave motion maintains the same speed throughout the medium. So this thing you need to understand. Well, so let us continue our concept with one more example, children. So here we go. Well, for this let us consider a large scale, something like this. Okay, through this large scale, let us hang 7 strings, something like this. 2, 3, 4, 5, 6, and 7. Okay, to a large scale, what we do is we suspended 7 strings. Okay, and for the 7 strings, one thing you understand, children, last 2 strings, the first string and the 7th string, 1, 2, 3, 4, 5, 6, 7. Okay, so let us name this. This is your first string, second string, third string, fourth string, fifth string, as well as 6th and 7th string. Let us keep all the strings at equal distances apart from the 1 and 7. So these 2, 3, 4, 5 and 6 have maintains the same equal distances, whereas 7 and 1 were kept a bit farther away, something like this. Now what we do is, let us suspend some pendulum bobs for all the cases. Okay, some pendulum bobs. So these are the pendulum bobs that we are suspending for all the strings that were hung. Yes. So what we do is, now if you start vibrating, let us start vibrating the one pendulum in the plane of paper. In the plane of paper means something like this. Before that, what we do is, let us take one more string. Let us take one more string. This is how we have to suspend the bobs. Simple pendulum. This is called a bob suspended to a string itself is called a simple pendulum. So these 7 simple pendulum bobs are being suspended as shown in the figure. So this is the first case. Okay, and we observe that the first and the 7th pendulum bobs are kept a little far away distance, whereas the 2, 3, 4, 5, 6 are kept at equal distances with equal lengths. Whereas the length of first and 7th is little larger when compared to this. The next step what we are going to do is, one, 2, 3, 4, 5, 6, 7 suspended with a large scale. Let us take one more string. Let us take one more string and try to tie not all the things overall. Okay, something like this. This is one more string, and let us try to tie all the strings, tying all the strings together. Okay, like this. Then what happens? Let us tie it tightly so that it will become something like this. knots are being kept all together. So that means there is a connection for each and every string, and whenever it is strung like that, let us maintain an equal distance for all the 7 pendulum bobs. Then what happens, instead of hanging like this will come something like closer to this. So as a result, this will move with the equal distances as shown in the earlier. This also moves to the equal distances. This was bent a little. Okay, it is tied in such a way that the same structure, after tying with one more string such that knots are being kept for all the strings, then the distance between the 1 and 2 is decreased, and even the distance between the 6 and 7 is decreased, such that all the pendulums are maintained at the equal distances. So when this is clear, next what we do is, let us try to disturb the first bob. So this is your first bob. What we do is, let us try to disturb this a little in the plane of paper. That means a small disturbance is created such that this pendulum bob will be oscillating. The complete string will be oscillating to and fro. Okay, such that this will not come in contact to the second pendulum bob. So it simply oscillates at this position along with the string, like this, something like this, children. So this will be oscillating something like this, but such that it won't touch the second ball. That won't touch the second ball. Even though after a while you observe that all the pendulum bobs starts oscillating even though they have no contact with each other. So what is the reason behind that? That means from this will explain us. Okay, so this example gives us more clarity that how a disturbance is carried from one region to the other region, okay, without the actual movement of the particles, because all the pendulum bobs will oscillate at their mean position. First one will oscillate at this position without touching the second will start oscillating at the same position without touching the third will start oscillating at their position, so on and so forth, and the same disturbance is being carried through the string to all the bobs, and finally we observe that even the 7th pendulum bob also starts oscillating. Okay children, this is how a disturbance is carried from one particular position to the another particular position without the actual movement of the particles. I hope this is clear children. And one more thing, so if you are clear with wave motion, you also need to know something regarding the pulse. Children, what do you mean by pulse? A continuous disturbance is called as a wave or wave motion. Okay, but what do you mean by pulse? Means simply a single sort of disturbance. Suppose if I utter a word something like that, then that is a single sort of disturbance. Or one more thing I can say, it's simply just clap a hand. Okay, a single disturbance is produced at a time, but when I am speaking out, the disturbance is continuously being produced. Okay, so that is a wave motion, continuous disturbance. But a single disturbance like clapping a hand or like that is called as pulse. Okay, and you also need to know that wave is generally carried like this. This is the structure how a wave is propagated from the point of disturbance to the other places. Okay, motion of the wave. And if you consider only one particular thing, suppose from here to here, this is a single pulse. Okay, only single wave form is called as a pulse, whereas the multiple continuous disturbances is called as a form of wave. Pulse and wave makes a difference. Okay children.